Learn beyond the infinity. Future starts here.
Hello everyone, welcome back to the Quantum Explorer. In today's video, we will discuss about sorting part 2. Today's topic of sorting is bubble sort. We will do explanation and the pseudocode for it, and we will discuss the time complexity about the bubble sort at last. Let's begin. Is the concept of bubble sort. Bubble sort has concept that compare adjacent elements, check larger than swap it. What it means. I have arrays 23, 39, 17, 64, and 8. What I do in my step 1. In my step 1, I will compare 23 and 39. Is they are in sorted manner? Yes. Then I don't do anything. I move further. I compare 39 with 70. Is there in sorted manner? No. So just I swap them. Instead of 39, 17, I will write 17, 39. Then I compare this 39 with 64. Is this in sorted manner? Yes, it is. So I don't do anything. Next I compare this 64 and 8. Is this in sorted manner? No. So I just swap it. And it will look 88 and 64. So here you can see in selection sort, what we do minimum. At first we select the minimum and put them to first index, but in bubble sort, by swapping we put maximum at the last index. Here you can see 64 is the maximum and it comes at the last index after the ending of first step. Means first iteration. What is second step or second iteration? Here again we start. We compare 23 and 17. Is this in sorted manner? No. So we swap it. Write 17 and 23. Again we compare. Is 23 and 39 in sorted manner? Yes. Don't do anything. Again, is 39 and 8 in sorted manner? No. Then I swap them. Now the main question is that, is there any sense to compare them? Although we can do, but no any sense, because after ending of first iteration, this element is the largest, which is come at the last index. So it already is largest element in this particular array. So of course the second last element is the not largest. So we not need to compare it. So here we loop, we stop at n minus 2th index. How I write n minus 2, I will tell you in code. Start. I compare this 13 and 23. Is this in sorted manner? Yes, I don't do anything. Is 23 8 in sorted manner? No. So I swap them. 8, 23. Again, there is no sense to compare this 23 with this part or this element. Why? Because they two are already in sorted manner. Again I start. I compare 17 and 8. Is there in sorted manner? No. So I just swap them. And at the end of four step, we get our answer. As you can see, we have sorted array. So this is the concept behind our sort, that compare adjacent element every time, check if larger or not, and that. So web then. What is prerequisite to write the code? You must know how to swap, which is available in our YT channel, the question on lead code. You can watch out it. Understand the writing of code by also having some conceptual logic. We write logic parallelly and write code parallelly. In first loop, or I can say in first step, I iterate from 0 to n minus 1. I swap, I compare this two, I compare this two, this two, this two, and this two. The size n is equals to 5 and I go for 0 to n minus 1 means up to 4. In next time I go for 0 to n minus 2 means I compare after ending the first step. 64 is the fourth index and I compare this one, and this one. After I go to 0 to n minus 3 to where I go to 0 to 1. I am not going to 0 to 0 because again at the end of last step I don't need. For an example, in this question at the end of fourth step I get this array, so there is no logic to again run the one further step and compare this 8 with itself, because a single element array is already in sorted manner. Okay, so I go to n minus 1, n minus 2, n minus 3 up to 1. So can I say that this is my I? Every time I starts from n minus 1 and decrease by 1, you can see, until I become 1. So this is my first logic which I write. My first will be 4 and I is equals to n minus 1 to I less than 1. I minus minus. This is my first loop. Inside this second loop, what I am doing is that I am starting from 0 and going up to I. I write and I explain it. For int j is equals to 0, j is less than I minus 1 and j plus plus. What it means? It means that every time I iterate j is equals to 0, j is equals to 0, 2, I less than or equal to I minus 1 means my I is n minus 1 towards. Let's say in this array 23, 39, 70, 64 and 8. This is my 0, 1, 2, 3, 4. What I am doing here, my I start from n minus 1. Okay, n minus 1 means fourth. Go up to 1. Okay, and my j start from 0. Okay, my iteration starts from 23 and I go till what? I minus 1. What is my I? My I is 4 and I iterate up to 3. How it means? First of all, I compare this one, then I compare this one, then I compare this one, and I compare this j with this j plus 1. Inside my for loop, what I do, I compare adjacent element. So here I write if array of j is greater than array of j plus 1, it means that if I compare, I go, first of all, my j is this, my j plus 1 is this. Second time, this is my j plus 1. Then this is my j and this is my j plus 1. This is my j and this is j plus 1, and my j is equals to I minus 1 minus 1. And if I don't do here j less than or equal to I minus 1, it again move further this and j become my last index, and there is no any element to compare with it, so it will give a runtime error. So this is why here I write I less than or equals j less than or equals to I minus 1. Here we swap this array of j and array of j plus 1. How I do that? I do here integer temporary variable array of j plus 1, then my array of j plus 1 is equals to array of j, and then my array of j is equals to temporary. This logic is also available in our YouTube channel. So this is the pseudo code behind this bubble sort. Let's write code, but I never write in VS Code. I write inside this panel. This is your duty to write in VS Code. So let's write the final code. I have this end main function. Inside this main function, I declare integer type variable n, take input from user of n, declare an integer type array of size n. I take input from user of elements of this array. Then I call the bubble sort function and I pass my array and size, and after calling this bubble sort function, I again print this array to see if it is sorted or not. Inside my this bubble sort function, I declare two parameter integer array and its length int n, and inside it I write my full code which I write earlier, whole code behind it. And at last, after ending of this bubble sort, I will return, or I can say I will printf by all elements of array. It you can do by your own. Let's talk about time complexity of this bubble sort. Here you can see we in first time we go to we iterated minus 1 time, then we iterate n minus 2 time, then we iterate n minus 3 time up to 1. So it is again and how many times? N minus summation of 1 plus 2 plus 3 up to n means n terms. So this is n square minus n into n plus 1 divided by 2. So it is looks like n square by 2 plus n by 2. But the rule of time complexity is that neglect constant and neglect the shorter term than the higher power term. So ultimately, time complexity is n square, and we can represent it I pick O and square, and this is the worst, or we can say average time complexity. What is best time complexity? Best time complexity is that the given array is already sorted. So this is the whole about bubble sort. I hope you understand. In next many videos, we will discuss about more sorting problems.